In this video, we are going to learn about efficiency. We are going to talk about what efficiency actually is, and we are also going to calculate efficiency. We have learned before that energy can be transformed from one form to another, but it is not always transformed into the form that we want because devices like this light bulb here are not 100% efficient. So let us look at the light bulb in more detail. The input energy for this light bulb is electrical energy, and the output energy, the energy that we get out, is light energy, but also thermal energy or heat. Now, out of these two output energies, light would be the useful energy output because that is the form of energy we actually want to use when we switch on a light bulb, and thermal energy would be the wasted energy. We don't actually use this form of energy here. So the efficiency is the proportion of input energy that is transferred to useful energy output. So in this case it would be the proportion of the electrical energy that is transferred to useful light energy. To calculate efficiency, we use this formula: useful energy output divided by total energy input. So let us assume that we have an electrical energy input of 300 joules here, which is transferred to 30 joules of useful light energy and 270 joules of wasted thermal energy. Now we just have to choose the correct numbers and plug them into our equation. The total energy input is 300 joules and the useful energy output is 30 joules. So we get 30 joules divided by 300 joules. And this gives us an efficiency of 0.1. A common mistake to make here is to put the numbers the wrong way around, so you get 300 joules divided by 30 joules. However, this would give us an efficiency of 1.1, and this would mean that we get more energy out of the light bulb than we initially put in, and this is clearly impossible. So a good thing to remember is that efficiency is always smaller than 1. So if the value that you get is bigger than 1, you have made a mistake somewhere. Let us look at another example. The blades of the fan are turned by an electric motor. In 1 second, the motor gets 200 joules of electrical energy from the mains supply. Only 100 joules of this energy is used to turn the blades of the fan. Calculate the efficiency of the motor. So our formula is efficiency equals useful energy output divided by total energy input. Now pause the video and have a go yourself at calculating the efficiency for the motor of this fan. The useful energy input here is the 180 joules that are used to turn the blades, and the total energy input are the 200 joules from the mains supply. So this gives us 180 joules divided by 200 joules. And this gives us an efficiency of 0.9. Something else that you might be asked is how much energy is wasted. To find how much energy is wasted, you have to take the input energy and you have to take away the useful energy output. So in this case, this would be 200 joules minus 180 joules, and this gives us 20 joules of wasted energy. Now we are going to look at a slightly more complicated example. In this case, we have a TV which has a useful power output of 800 watts and a total power input of 1 kilowatt. And we have to calculate the efficiency of the TV. The equation to calculate efficiency was useful energy output divided by total energy input. If we are given power instead of energy, we can just change that to useful power output divided by total power input. Now again we just have to plug in our numbers into the equation, so we get 800 watts divided by 1 kilowatt. However, now you might notice that there's a slight problem with this. We have two different units here. We have watts and kilowatts, and we have to convert them so we have the same units. The easiest way to do this is to convert the kilowatt into watts, and this is done by timesing by 1000. So 1 kilowatt equals 1000 watts. So then we get 800 watts divided by 1000 watts, and this gives us an efficiency of 0.8. And this is all you have to know about efficiency.